Hello, a quick introductory video to the basics of transformation of graphs. We quite often have a sort of base graph in our head, don't we, like a quadratic, a cubic, and we've got a fundamental one like y equals x squared or y equals x cubed or something like that. And what we find is the relationship in practice has been sort of translated and it's been stretched, or it might even be reflected. And one of the issues for us is people getting confused about the direction of a translation or the scale factor of a translation, particularly if we're operating in the x direction. So let me take us through and look at a few basic ideas. Okay, translations. I'm going to use this function here, a cubic, here it is up here, to demonstrate this. The reason I've written it in its factorized form is so that we can see where the three roots are. So for the first factor, that's got a root of -1, the middle factor, that's got a root of 0, and the right hand factor has got a root of +1. So looking at our dotted blue line, that's our base here, we've got those three root points. Okay, let's start by translating this 0, this curve 0, 1. So we're going to move it up +1 in the y direction. So each of these points has moved up. There we go, +1. So I think it's easy to see what we've actually got. The equation of our new line is the equation of our old line, and then we've added +1, haven't we? And if we rewrote that in function format, that's our original function +1. So that looks pretty straightforward, doesn't it? Okay, let's have a look at what happens if we want to translate in the x direction. So let's go with a 1, 0. So we're going +1 in the x direction. Well, we can see that each of the points on our original curve has been moved across +1. That's what we're trying to achieve, isn't it? And we can see down here that our three roots have also been translated along as well. So rather than being at -1, 0 and 1, they're now at 0, 1 and 2, which means you could see that we could rewrite this cubic equation quite quickly in that form, because these are factors, aren't they? These are our factors, so that's got a root of 0, that's got a root of 1, that's got a root of 2. Now we could see algebraically quite quickly that what's actually happened is we've taken our original function, and rather than having x in it, we've replaced x with x and -1. Okay, go and play on GeoGebra and convince yourself that that's true if you need to. But that's basically what's happened if we write it in function format. So interestingly, we've got a +1 direction, but we've got a -1 inside the bracket, haven't we? Well, why is that coming about? Well, actually, let's take a point here. What's this one? This is something like 0.2, isn't it? What we want, if we're going back to our original curve, is we just want an x value here rather than at 2 point, let's go at 2.3. We want the x value in our original curve of 1.3, don't we, to get to this point here, to get that y value. And how do you get from 2.3 to 1.3? Well, you have to take 1 off. So in effect, we know we've got to take 1 off. So that means for every number, we're going to need 1 more, aren't we? That's our 1 more bit, our translation. But effectively, to undo that, we have to take 1 off, put it into our function. Okay, let's have a think about how. So it looks like at this point that these are operating in different directions, doesn't it? The way that the x and the y's are working. Well, a lot of teachers teach it like this, and they think about what's going on as a function of inside or outside our function bracket. Well, if it's outside our function bracket, like here fx +1, well, that's having the effect of, it's affecting our y value. We saw that moved it up, didn't it? That was our 0, 1. It's affecting our y value, and it's doing a +1. Now that appears on face value to be very different to what's happening in the x direction if it's inside the bracket, where the effect appears to be it looks like it might be reversed, but it isn't. We have to put a -1 in rather than a +1. And if we just rearranged our y move one here by just taking -1 from both sides, we would see that y -1 would equal fx. So that's our outside the bracket, and which is the same here that what happened inside the bracket where we had our x -1. So effectively they are doing the same thing. But the principles here that a lot of students remember as above, that if our translation is outside the bracket, then if it was a +1 outside the bracket, then we're going to move 0, 1 in a positive direction. Whereas, let's see if we have an fx +1 there, fx +1, yeah. But if it's inside the bracket, if we had an f of x +1, it would actually be moving it in the opposite direction. Yeah, so it would actually be moving it -1. So that's what you have to watch out for. So outside it's doing what you expect, inside the bracket it's having the opposite effect in the translation. Okay, let's have a quick look at a stretch then. Let's stretch in the y direction, and we're going to multiply it by a scale factor of 2. So this point here, which is about at 0.4 or something, isn't it, is getting doubled and moved up to there. This point here, which was originally at 1, is being moved up to 2, isn't it? So that's the effect, as points are being stretched in this direction, aren't they? We're getting our stretch in that direction. And we could quite easily see that intuitively we've got our original equation, and we've just the y values have just doubled, haven't they? So we've multiplied by 2. If we wrote that in function form, we've got our original function multiplied by 2. The 2 is on the outside of the function bracket, and therefore it's having what we would expect intuitively to be the right effect. It's stretching it, it's scaling it up in that direction. Okay, now let's have a look at if we used a scale factor of 2 in the x direction. So this point here is going to be moved to there. That point there is being moved to there, and similarly this point is being moved to there. These points being moved to there, yeah. So we're doing a scale factor of ×2 in the x direction, yeah? Okay. Now, if we tried to write the equation of this new line, we found that our roots, rather than being at, we had before at -1, one of our roots is now at -2. This one's remains at 0, and this one is at +2. And if we worked out the equation to keep the magnitude the same, we'd find that the equation of our new line would be this. We'd have x over 2, so that gives us our root of -2. X over 2 here just is giving us our root of 0, plus keeping the scale correct, and our x over root 2 minus 1 gives us our +2 root there, doesn't it? So that's why it's like that. But if we have a look, what we've actually done is we've got our, if we looked at it in our function format, we've got our function here is our function is of x over 2. So we've replaced our x value all the way through this with x over 2. So to have a scale factor of 2 in the x direction, we actually had to divide by 2 inside the bracket. So effectively it has the opposite effect again. So why is this? Why does it appear then that we're doing the opposite effects for y and x? Because in one it was a multiple of 2, scale factor was 2, and in the other one the scale factor was a half. Well, again, if we look at this these formulae, that was our original y one. It was y equals 2 over fx. But actually, if we 2 times fx, but if we then divided this equation by 2, we'd end up with our y over 2, which is what it was actually affecting, equals of f of x. Yeah, which gives us the same format as we've got here inside if we did the x scale factor stretch. it's actually x over 2 here, isn't it, inside the bracket. So can you see again that what's inside the bracket, whether it's inside the bracket or outside the bracket, has a real impact. If it's outside the bracket, it's as you would expect, and if it's inside the bracket, it's having the opposite effect. Okay, so that's one of the key learning points in this, is if you're working with an x and something inside an x function, it's going to be having the scale factor is going to have the opposite effect to the one you would expect. Okay. So a quick look at reflections. I've used a different function here so that we can see what's going on. So I've used the f of x here is 2 to the power x. Okay, so let's have a look at what would happen if we want to reflect this in the x-axis. So effectively we're changing our y values, aren't we? And what we find here is that this point here heads down to that point there. So our y values become the negative of the original. So we can see that our function of fx equals 2 to the x, the function of our curve here, the equation of our new curve is minus 2 to the x. So once again, we've got our original f of x, and we've put a new function change outside. Here we've changed the sign of the whole thing, but it's outside the bracket. So it's outside the bracket, it's having the effect in the y direction, and it's what we would expect, isn't it? Okay, so have a quick look then at what happens if we want to reflect in the y-axis. Here's the y-axis, there we go. So if we were reflecting in this line, this point here is going over to there, and that point there is going over to there in this reflection, yeah? That's basically what we're looking at. Well, what's the equation of this new line here, the purple line? Well, that is going to be 2 to the minus x. Well, why is that? Because the value we're looking for over here, the value here is going to be the one for the negative x value for what we had before. So here we're seeing that the change to our equation, here it is inside the bracket. Okay, and it's having that effect on our x, isn't it? It's having the effect on our x. So anything inside the bracket's having an effect on our x, anything outside the bracket's having an effect on our y. Okay, so let's summarize what we've just looked at there. The first part is different transformations. If we're working outside the bracket, then things happen as we would expect. Yeah. So here, y equals fx plus 1 is a translation in the y direction. So that's a 0, 1. Yeah, that's as we would expect. And we've got a 2 out, and the second one here, we've got y equals 2 to the fx. Well, that's giving us a stretch in the y direction with a scale factor 2. So both of those are as you would expect. But what happens if we got functions, operations happening inside the function bracket? So here's x plus 1. Well, what's actually happening here is this is a translation in the x direction, and it's going in the opposite direction to that we'd expect. So it's gone and taken us in a minus 1 there, isn't it? So that will be minus 1, 0 would be the translation for that. And what if we have a 2x inside the function? Well, actually, rather than being a stretch with a scale factor of a half, as I have 2, we're getting a scale factor of a half. This is actually widening it out, and that's had the effect of using a smaller x value. So watch out, that's a scale factor there of a half. So that again is, if it's inside the bracket, it has the opposite effect. We also looked earlier at reflections, and in our reflections we found again that outside the bracket is the straightforward one. A reflection in the y-axis, sorry, the x-axis is what we'd expect, isn't it? That went to there, didn't it? That's what you'd expect. So again, being outside the brackets, doing what we expect of it. But if that minus is inside the bracket, it had the effect of reflecting in our y-axis. my general advice for working on these, and we're going to do a lot more in C in the second year, is always work out from the x value outwards and the function. If it's inside the bracket, you've got to watch yourself. If it's outside the bracket, you're in a pretty safe position because your intuition will work. Okay, hope that's of use.